All right, hi guys. I'm just going to go over this first page of this worksheet on graphing rational functions, section 8.4. For those of you who either missed class today or this is a tough lesson, so if you're struggling, you can come back to watch this. Okay, so to graph a rational function, there's a couple of steps we're going to have to go through. So the first thing we're going to do is factor if possible. And if you're able to simplify, make note of the point of discontinuity. So basically, a point of discontinuity is where you can factor and cancel factors on the top and bottom. Set canceled factors equal to 0 and solve. Basically, this is going to be the conditions that will make your denominator 0. Okay, so we basically, if we cancel these, where is the denominator 0? Okay, so where is denominator equal to 0? Okay, that we canceled out. Okay, so a POD, or a point of discontinuity, is where you can factor and cancel factors on the top and bottom. Then those factors that you canceled out, you just have to set those equal to 0 and solve, because if we would have plugged a number in there and got 0, the denominator would have been 0. Hence, we would have had a point of discontinuity. So an example of this is if we have maybe x plus 1 times x plus 2 over x plus 2. Right? We're going to be able to cancel those x plus 2's. But x plus 2 can't equal 0, so x cannot be negative 2. That right there would be our point of discontinuity. Okay? And that's because now when we graph it at x equals negative 2, right, we're going to have some sort of open point on our graph. Okay, you'll see a little bit more about this point of discontinuity as we go throughout these notes and do an example, but basically, if you cancel factors out, make sure you figure out what x cannot be from those factors, because that will affect what your graph looks like. Okay, so basically find the domain. Step 2 is to find the zeros, aka the x-intercepts. So to find the zeros, all you have to do is set the numerator equal to 0 and solve. So set num equal to 0 and solve. All right, that's all there is to it to find the zeros. Okay, so these are where your graph is going to cross the x-axis. All right, then we're going to move on to our vertical asymptotes. So to find your vertical asymptotes, you just set the denominator equal to 0 and solve. All right, so those ones are really easy. Okay, step 2, step 3 are really straightforward. Okay, step 4 are horizontal or oblique asymptotes. Okay, these are going to be our asymptotes that are going to go kind of straight across or going to be slightly slanted on our graph. Okay, to do this, we are going to have to kind of look at the degree of the numerator and the denominator. Okay, so I said here n represents the degree of the numerator, d represents the degree of the denominator. So if the degree of the numerator is greater than the degree of the denominator by exactly, or by more than 1, okay, if it's greater than the denominator by more than 1, then there is no horizontal asymptote. So no horizontal asymptote. If the numerator degree is greater than the denominator degree by exactly 1, get rid of that more, so by exactly 1, okay, then we have to do a lot of work. There's going to be an oblique, asymptote. And to find it, you'll have to use long division to divide the numerator by denominator. Okay, and this is going to give you some type of function, something like x equal or x minus 1 or x plus 2, because this oblique asymptote is going to be an actual line. Okay, so it's going to be something like this, maybe x minus 2. All right, then from here it's pretty simple. If the numerator degree is less than the degree of the denominator, then the horizontal asymptote is at y equals 0. Okay, so that one's straightforward. And if the numerator degree equals the denominator degree, then there is a horizontal asymptote at the leading coefficient of the numerator over leading coefficient of denominator. Okay, so as an example here, if I had 2x squared plus 1 over 3x squared minus 1, the horizontal asymptote would just be at 2 over 3, y equals 2 over 3, okay? Because all that is setting the LC over the LC. All right, and then once you get through that horizontal asymptote, which is the hardest part, now you're just down to graphing. So you're going to draw any of the PODs, zeros, or asymptotes that you found in steps 1 through 4. Okay, and then all you do is use a table for a couple more points and graph. All right, I know a lot of that was hard to understand without examples. So if we go through the notes, these notes are identical to the examples in the book. Okay, so you can use the book if you weren't in class. But we're going to go through a type of each type of asymptote, okay, and the PODs, so that'll make more sense. All right.